a very, very fun display from 2003, 2004, somewhere in there. See, if you have it in 243, you've seen this before, you may have forgotten it already. If you didn't, take a look at it now, see if you can see what's going on. It's also a little bit dated, but I can't help but use it, it's great. Red, in favor of the war in Iraq. White, against the war in Iraq. Blue, don't know where Iraq is. Ostensibly, this is based on a random sample of Americans, and it's clever. They did this with a bunch of flags in a bunch of different countries. They did China, they did Somalia, they did Brazil, about a half a dozen. Cameroon, I believe, was in there as well. And what they did in each of these countries, can you see what they did in each of the countries? Yeah, they went in and looked, what red, white, and blue, what does that have to do with anything? What is being implied by the red, the white, and the blue? Alan?
Each color represents the population.
Exactly, or a percentage of it, if that's okay. So in other words, the red, if you look at the red on this flag, which makes up roughly how much of the flag? Ish. 40%, something like that. Good, 40%-ish of the flag. 40% are in favor of the war in Iraq, when at the time this study was done. How about the white in the flag? Ish. How much? Almost the same? Now, some of you might go, it's hard, because there are white stars, but there aren't red stars. But there's also one more red stripe than there is a white stripe. I don't know if you know that about the American flag. Do you know why there are 13 stripes on the American flag? 13 colors. Good! Excellent. Okay, I always wonder about East Coast versus West Coast history lessons. I always wonder about that. So, 13 original colonies, 13 stripes. I think it's one of the more clever flags in that respect. So, there are 7 red, 6 white. I also think it's interesting that we have this interesting pattern of stars, 7, 6, 7, 6, 7, 6, that sums to 50. So I hope we don't add another state and screw up the symmetry.
6, 5, 6, 5.
Well, this picture I think it's cut off. I believe there's actually one more line. The picture got kind of chopped down. And speaking of which, if you go online, there is actually a congressional website that tells you if you want to make an American flag, you have to make it the correct dimensions. Like the entire flag has proportions. So if you call that 1, then you have to make that one, that one, that one, that one. That field needs to be exactly 6 stripes, and it needs to be exactly however wide it is. So next question is, what percentage is blue? What percentage is blue? 25? 20? Very good guesses. 19.7. I did the math on this one myself. I actually figured out how big a star had to be by the congressional thing. I multiplied it by 50 and subtract that away from the rectangle blue. All right, 19.7%. Okay, so we're going to use that figure because now we know what 19.7% is, assuming that it's the same percentage that they found in their study. Couldn't find Iraq on a map. Are you ready? All right. Oh, Nick, go ahead, question.
Why does it say meet the world when it's the American flag?
Well, because the whole series involved flags from all over the world. Okay. Brazil, remember the ones we looked at Brazil, China, and America in our 243 class? There was about, I think, 6 more. So that's why it says meet the world. This was just the one particular one that I could find data on. Okay, friends, do not call out, do not use your smartphones, do not log into any kind of a network. Find Iraq. Find Iraq. Don't point. Don't tell your neighbor. Find Iraq. $28 people. All right, we got a sample size of 28. All right. Who knows where it is? Who knows where it is? M, come show us.
I can't reach that.
Oh, well, we have a laser pointer. We have no laser pointer.
I'll pretend I can reach.
Guide me.
To the left. To the left. And you're there.
Who found it? Okay, good. Raise. This is not to do anything except to test the 19.7%. So raise hands if you found it. Found Iraq. 1, 2, 3, 4, 5, 6. 6 found it. Which means 22 didn't. 6 found it. 22 didn't. Very, very small sample size. Right. 28. I want to see if your guys' lack of finding Iraq is significantly worse than it was when they ran that article. See what I'm saying? Now, if I treat you as a population, we're done, because it is, right? Right? If we treat you as a population, we're done. The original population was about 20%. Or the original precision was, so 1 in 5 people couldn't find it, correct? 1 in 5 people couldn't find it. According to us, 22 out of 28, which is way more than 20%, couldn't find it. So if we treat this as a parameter, there's no point in doing the study, because we're done. The problem is, if we treat you as a sample, we also have to conclude a what? A margin of error. So some of you go, wait a minute. It's so vastly different. I mean, it went from 20% in the original study, it looks like it's closer to, what would that be? If I call that 25 times 4 times 4, it's like 75% now. How could 75%? I'm not saying that 75% isn't more than 20%. I'm saying that if you put a margin of error on there, depending on how wide it is, it might gobble up the original 19, which would mean we can't actually tell that it changed, as large as it might be. So the problem is the teeny tiny sample size of 28. I want to see if that drives our p-value up. I don't know if it will. I can't do the math in my head. This is why we have the templates in front of us. Grab a new template, new test, new test. Oh, and I also brought maps. If you want to cue your neighbors, collect some more data and bring it back, we can refine our estimates. So here, we'll leave these here for you too. Bring a map. I have the map right here. And then on the back, grab 2. The printer in our office pisses me off. Because I said print on 2 sides, and this is what it means by 2 sides. Anyway, grab 2. Here's the map. Here's the right or wrong. You can keep track of if they get it right or get it wrong. Bring the data back on Monday or on Tuesday. We'll look at it again. Put that right there. Okay, so let's clear this up. Let's turn this off. All right. Let's erase what we can erase, and replace it with. Let's replace it with new stuff. So, Di, going back to your question, which is also about, as a researcher, what I do. So, I'm thinking, well, let's get to that in a second. First of all, what variable are we testing again? Why mu?
Because it's a mean.
But it's a mean what?
Well, it's not a proportion anymore. It's like a binomial, or not a binomial. It's yes or no. It's
So it is binomial.
Oh.
Yes or no?
But what's the statistic word for it, though? What kind of?
Yes or no? Binomial.
It's binomial?
Yeah, it's 0 or 1 off or on, right? Off or on.
No, but like
No.
you know, there's discrete and continuous, and like which one of that is it?
Good. I'm going to turn that question around if you don't mind, Mel.
Okay.
Discrete or continuous? A very quiet vote for discrete, a second for discrete, a third for discrete. If I asked you to find Iraq, you either can or can't. So it's discrete. So it's still a proportion. What percentage of you found it? Or what percentage, in this case, what percentage didn't find it?
75.
Is that good? We're going to come back to that, Nick. Thank you. So you see why it's still going to be proportions. What I didn't ask, see, I think what you're thinking, Mel. Remember how I put the marker and I said M? I said M, let me know where it is, and I slid my marker in. If we were talking about how far off I was from the center of Iraq, that would be a continuous variable, the distance from the center. But since it's either you could or couldn't find it, it becomes discrete. Is that fair? Because I want to look at 22 out of 28. Boom, that's going to be my data. So I know what my data is right now. 22 of you couldn't find it, and 28 of you gave it a shot. So it still fits the bill for a proportion. Is that fair?
Yeah.
Good. Thank you for that. See, what Mel's bringing up is that this is what you have to deal with when you're confronted with data. Right now, it's all coming to you. We're testing the same data, same kind of data, proportions. Next up, we'll start looking at averages and why we have to change the kind of the scope of what we're looking at. But right now, it's proportions. But identifying why it's a proportion. Something out of something that makes it proportional. That makes it binomial, that makes it 1 or 0. Mel, is that fair? Great question. Good! So we are testing little p. What is little p? What am I interested in right now? I'll start with the proportion, or the percentage, or whatever. People, good. What percentage of who they can't find Iraq? I want to call you a very biased sample of COCC students. How about that? You could put percentage of those who can't find Iraq. You know what? Even better. Percentage of those. Let's do this. Percentage of those who can't find Iraq in 2014. How about that? I'll use you guys as the worst possible sample of that. Why? Because I don't like you? No, I love you all. Why are you the worst possible sample of those in 2014? Number one,
Or small sample.
you're a small sample. That's the least of our worries, but yes, very good, Nick. Yes, small sample. I can live with a small sample as long as it's good data. That is the problem. You're a convenient sample. You're not good data. Well, you're awesome data. Don't get me wrong. But you're not good representative data of the population because you all came here at 8:15 to sit through my bad jokes. So you're a convenient sample. You're all COCC students, or you're split dual enrolled OSU, Cascades, or you're just OSU Cascades. So the problem is you're not representative of the general population. You're not even representative of a student population because you're all taking statistics classes. So again, it becomes, you're a loaded sample, right? That's why I want to take the map with you and go get more data. Go ask your friends, go ask your neighbors. That won't be much better, but it'll be slightly better, right? You get some outside data sources. So bring it back on Tuesday, we'll test it again. And we're not done testing this yet. So, what's my belief? Now here's where goes back to Linda's question again. What's my belief about the percentage based on what I just saw in those results? What's my belief about the percentage of those who can find Iraq? It's greater now than it was back in 05, 06, 07, whenever that map was put out. In the past, what, 5, 6, 7 years, the percentage has gone up. That's my belief. My belief is that it has gone up from the 19.7% that it once was. Thank you, Linda. Perfect. And this, back to your awesome researcher question. As a researcher, very often, you won't make a claim until you see your data. See, the Gainesville sum was kind of backwards. The claim existed in the paper, followed by the data. All you got to do is look at that data and realize the claim's off. It makes more sense to do it this way. Look at the data, and then test what appears to be true from the data, and see if it's just an outlier or if it's actually within a margin. Is that fair? And then retest if necessary. Yes, ma'am. Absolutely. So let's see if we are significantly higher. Look, we're definitely higher. But the question is the margin of error tight enough to not include that 19.7%? Again, we got to find out. I mean, we have to. It could be ridiculous. It could be 30 points wide. I don't know what it is actually right now. So, what's the opposite of that? It hasn't changed, or it's gotten better. Now we know it's not. If we are representative, we know it hasn't gone down. If anything, it's gone up, but it may have stayed the same based on our small sample. That's why I want more data. But we'll test this first. We'll test this first. So here we are. Here we are on our null curve containing 0. What number's in the middle of that 0? Or what percentage is under that 0? Yep, 0.197. Matt, impressed with you guys that we're estimating it at 20%, 25%. Nice job. Nice job. We think we're somewhere out here. If we think we're worse, we think we're going to land out here in this tail out here. And I know we're going to land right. I mean, for sure, 75% is this side of 19.7%. The question is, based on the margin of error, how many blah blahs is it to the right? How many standard deviations is it to the right? The standard deviation is wicked wide because the margin is going to be wide because the sample size is so small. And this goes into that ruler idea of how many standard deviations. It was either Emily or Melanie said that earlier about the standard deviation, the z-score. Natasha. Well, somebody said it today, though. I'm going to give props to everybody, all three of you. So the idea is we need a measure of, yes, 75 is more than 20. Is it truly statistically significantly more? Blake said he doesn't care. Good for you. Because it's ridiculously bigger. But again, if we want to apply this to a population, we got to put the margins on there as well. Good so far? Okay. What would a type 1 error be? False positive. Saying the percentage is higher when it actually isn't. So we make the claim that people can't find Iraq now even more than they could 7 years ago. But actually they totally can. Or they're totally not. They're finding I don't know how to say can, not higher. I've already made up enough words today. Yes, false positive. We said the rate is higher, but it's not. That's false positive. So we get a small p-value. We'll make that error. False negative. Good. Saying the rate has not gone up, but it has. But it has. And what's fun about this is I can't tell, because I can't do the math in my head of which way it's going to fall. I mean, I know it's to the right. It's not going to fall to the left. If it fell to the left, and I was testing that claim, let me just take a quick pause here, a mathematical one. If I was testing this claim, and the data fell over here, I wouldn't even need to do a test, because I know the p-value is going to be huge. This is what happened in the last test, right? We were testing that the Florida motorcycle death rate went up, but the data came back and it landed over here. Technically speaking, at that point, we could have stopped if we had just looked at that, because we know the p-value, because you shade this way, you shade whatever way it tells you to shade over there. We know that it's going to shade more than 50% of the curve, which is bigger than 5%. So we know right away we're not going to have a type 1 error, we're not going to have a less than 5%. The problem with this one is, we're thinking it's over here, we know it's going to land over here, we just don't know where it's going to land over here, in this region or that region. If that didn't make any sense, don't worry, it will in 2 weeks. That might have not made any sense at all. I apologize if it didn't. Crap. Damn it. Yeah, Lynn.
So is it normally saying that if you're using the greater than, that it's usually a type 2 error?
No generalization like that. That's just a function of what we're testing in the data.
Okay.
It has to do with how big the p-value is. P-value's big, type 2 is a possibility. And the type 2 could easily go this way. Right? It has nothing to do with which way it's shading. That's kind of a consequence of the data. Thank you for that question. All right, we've identified the errors. Which one's worse in your opinion, or do you not care? Don't really care. That's totally fine. This is meaningless data. Well, I don't really care about it, because at the end of the day, well, I don't know, maybe it's not. I think a type 2 is a little more indicative of the ugly American syndrome, don't you? This is my vote. My vote is type 2 would be a little more indicative of the fact that we suck. Because not only do we not speak, if you ever go to a foreign country and you try to speak their language and they laugh at you and speak perfect English, it happens to me all the time. Well, I shouldn't say all the time, I don't go to foreign countries all that often. But I went to Germany years ago, Switzerland years ago, to visit my sister. And I was trying to, I found a building, I worked at a school called Salesianum. And I found a building in Switzerland called Salesianum. I'm like, what the hell? What are the chances of seeing a Latin name in a Germanic, roughly Germanic area-speaking country, the same as the school I'm working at? So I'm freaking out. I'm on my way to climb the Zuckerberg mountain in the middle of town, and I'm dressed in my lime green wool hat, my camo cutoffs, and my goofy weird sweater, and I got a baguette sticking in my backpack, and I walk up and I knock on the door, and nobody comes to the door, and I go peeking in the windows, and I'm knocking on the windows, and nobody comes to the door, or the windows, and it's like, ah, the hell with it, I'm gonna keep walking, so I keep walking. The cops pull up behind me, and they start speaking to me in Swiss German. I'm like, oh, got this, and I'm like, Entschuldigen Sie bitte, and I spoke better German 15 years ago than I do now. I took 4 years of it in high school, and they start talking to me, and I realize they're accusing me of a crime, and I'm like, warum denn? And then we start talking about, and I realize that I can't speak enough German to understand their little dialect, and then the police lady goes, if it helps, I speak pretty good English. And I'm like, oh boy, you do. Better than me. So it turns out they thought I was casing the place. Now, granted, in a lime green hat in broad daylight, they thought I was casing a place in Switzerland. It's just FYI, we had a great laugh out at the police station later after I talked to him for half an hour, had donuts and left. But the point is that the ugly American phrase, and I'm a pretty decent German speaker, but I couldn't hang with the Swiss, which is, it wasn't even they have Swiss, French, and Italian all mixed together in that region, mostly German. My point is that type 2, in my opinion, if this was actually a study worth talking about, would be worse, because that would mean that we are lacking in maybe geographic skills, but we didn't see that in our test. You see, that's kind of my roundabout way of explaining that. That's my vote. It doesn't have to be your vote, it's just my vote. So, put whatever you want, including I don't care because it's meaningless data. That's a totally acceptable response as well. All right. What's distribution? Still Z. We're still testing using Z. Still normal distribution. It's a Z curve. You say that again? Why? That's such a great question, Em. Oh, Emily, that's a very good question. Wait, we got a really small sample. We got a really small sample. Shouldn't we use T? Oh, it's so good. My vote is no, only because of the type of data. It's discrete. But I love what you just said. That makes me so happy. Think of it this way. There is a check. Theoretically speaking, there's a minimum sample size you have to even use Z. Do you remember what it is? You can say no to this because it's been at least 3 weeks.
25 or 30?
It's pretty small. 25 or 30 was for the central limit theorem. That's totally fine too. There's a calculation you'd have to do. It's called NP. NP or NQ, depending on which one is smaller. So thank you, Em, for bringing this up. Either NP or NQ. What you'd have to do is you'd have to assume, okay, what is the value of P? What's the value? Well, P is about 20%, correct? What's your sample size? 28. So what you do is you do 28 times 0.197. What does that come out to be? It's bigger than 5, isn't it? That's the check. As long as that's bigger than 5, and I don't expect you to have remembered this, friends, at all. But I walked you through why we're using bell curves for binomials. You brought up something earlier about the bell curve, the idea of it's binomial. Why bell curves? As long as you can satisfy both of these are bigger than or equal to 5, then the bell curve kind of starts appearing in the sampling distribution. So thank you for that. We do have enough though. As long as we've got I think as long as we have like 20 people in the room, or 25 people in the room, I think it's golden. Because then it's the bare minimum. I'm not saying it's useful because the margin's going to be huge, but at least the bell curve is there, albeit wide. Such a good point, such a good point. So here's what I want you to remember. For proportions, use Z. For averages, use T. That's a quick and easy way of filtering through the process of what you want to test. Thank you, that was such a good question. Okay? I think we're ready. Let's test it. Let's go to the machines.
Such